Our guest this week is Roger Peng, and Roger is an author and professor of biostatistics at the Johns Hopkins Bloomberg School of Public Health. I've known him for many years, and the focus of Roger's research is environmental health, and he specifically focuses on air pollution and climate change. And he's also created numerous resources, including books, online courses, podcasts, and blogs. And we're going to be talking about some of those things today. So thanks for joining us, Roger.
All right, can you hear me okay?
Yeah.
All right. You're actually a little on the soft side, but just to,
Oh, yeah. How about now? Better?
yeah.
Yeah? Okay, good. All right, so let's get started. So let's start. I'm going to start by asking you if you're a applied statistician, a data scientist, or as Wikipedia says, a software engineer.
Is that what Wikipedia says?
It's one of the things it says. It also says you're an author.
Okay. I mean, I'm all those things, right?
Yeah, you're all those things. Okay.
I know. I think as I think of myself as a data scientist, I think that's fair.
Okay. So what is your definition of data science? I'm curious.
Yeah. So I have to give the long answer for this.
Do it.
So I think, I think of data. I think there's a lot of people trying to figure out what is data science, what is the field of data science, and I think when I think about like a field in terms of like defining it, I try to think about what is it that all data scientists do, and what do they study, and kind of what is the one thing that can we all care about. And I think for me, it's the process of learning and of the process of kind of extracting information from data. And very specifically, it's a kind of, we always talk about, whenever we talk about data analysis, we always talk about kind of an iterative process, especially for like exploratory analysis, things like that.
Mm-hmm.
But I find that in a lot of the literature, it's like no one ever talks about exactly how that process works. And I think, so I think all data scientists focus on this kind of iteration of of looking at data, developing a set of expectations, seeing how the data match those expectations or not, and then figuring out what to do about that next. And this kind of cyclic process, when I think about who are the good data scientists out there and what makes one data scientist better than another, I think about this process and how some people are so good at the various elements of this kind of cyclic iteration.
And how is that not an applied statisticians? Like weren't like Tukey and even Fisher doing things like that?
Sure, yeah. I mean, I think it wasn't at Cleveland who came up with the term data science. That was must have been in the 70s or so, right? I mean, so I think so. I think it might be a matter of degrees in terms of the terminology. I think today there's two things. One is that I think there's more opportunity for. I think if you think of the multiple hats that you might wear as a data scientist, there's statistician, there's kind of systems engineering, kind of understanding complex systems.
Mm-hmm.
And then I think there's more opportunity to do some of those things like be a scientist, or kind of make decisions as a scientist. And also I think the complexity of the systems that we build now is far greater than what was in the 60s and the 70s. And so the ability to kind of examine and diagnose problems and to kind of modify and revise our kind of statistical machinery is really critical, and obviously involves a lot of knowledge about software and software engineering.
So you said that Cleveland came up with it, and there was a Wu at Wisconsin actually proposed it as a change, as a name change. I don't know, in the 80s, 90s. But one thing that I've learned is that there was another proposal in, I think it was like the mid-Augies, where Patel, DJ Patel, is that how you say that name?
Yes.
He wrote this with another author, which I can't remember the name. They wrote this paper in a business review, and they claim to have come up with that name, and they probably did, because they probably hadn't heard all this the previous statisticians talk about. I mean, that wasn't like that well known, and it seems like that what they were talking about was basically data wrangling. Like that's what they were saying. Like this is like there's all this other stuff that statisticians do and computer scientists do, but we find in the business world that it's really data wrangling that matters much more than it does in academia.
Yeah.
So they came up with the term.
Yeah.
And then the academics were like, wait a minute, we do that too. And which it was true. I think it was true that, for example, like in genomics and in astrophysics, they were doing that. They weren't calling it data science, but they were doing data wrangling and software engineering and all these other things.
Yeah.
So I think that the term arises because, because there are people doing all these things that we didn't teach in academia. So even though some statisticians were doing this, some astrophysics people were doing this, some genomics people were doing this, they weren't teaching it. They were doing it and publishing papers, but it wasn't like in your face when you're a student in university. You take a statistics course and you're learning about the t-statistic and distributions and all that other stuff. So so I view it as an umbrella term that includes many things, include data analysis, which you're focusing on, but also some of the engineering aspects of it, including data management.
Well, let me ask you this question: who's not a data scientist?
That's a good question,
right? I think you have to think about this, right? Because it's like it's very easy to fall into a trap where it's like it's everybody.
Yeah, it's true.
Right.
But so I will answer that. I mean, if you tell me a name, I'll say that's not a data scientist, right? I mean, don't do it now. But I mean, if you're serious about that question, I can say all the theoretical people aren't data scientists. I mean, someone doing algebraic theory isn't a data scientist, or someone doing, just like writing economics paper based on theory or ideas, not necessarily on data. But I get your point. Like if scientists that are using data to make decisions, they could call themselves that. Yeah. But I would say that I would reserve the name to people whose main task is that part.
Well, yeah, I think you have to ask, like, what do data scientists study, right? They don't study biology. They don't study computers. They study, I think the only thing that you can kind of bring it down to is that they study the process of analyzing data, right?
Mm-hmm.
And that includes the methods that we use, the tools that we use. So, what are the operating characteristics of the tools that we use? But it also, I think, should include, and I guess this is me talking now, I think it should include more things that don't necessarily involve data, but are part of the data analytic process.
Right. So give me a second. I don't know if you heard that.
Maybe I should play some more music.
Hi. Sorry about that. So
no problem.
Yeah, but let me ask you this: do you consider people who develop the backbone of databases to store data and develop the software to optimize the way data is stored and accessed, do you consider them data scientists?
That's a good question. I mean, I'm tempted to group people like that into the theory end of things.
I see.
Yeah. So if you're writing software, I mean, I think there's an element of you have to design the software, right? And so that has to be informed by how it's going to be used and things like that. But I think if there has to be an element of like you're in the practice of kind of learning from the data, and you're studying that practice. And I think if you're building a tool for others to use, I think that's extremely valuable. But if your interest isn't kind of in the data element, then.
So are you saying that, would you say that the people that develop RStudio, they're not data scientists?
I see where you're trying to lead me here.
Yeah. Well, I mean.
Well, okay. I mean, I think, first of all, RStudio is not some little company anymore. They've got like hundreds of people working there, right? So.
Okay, so let's say the people that develop packages for others to use.
Well, I think it's fair. I think it's maybe most revealing to indicate that I think only recently, maybe as of this year or last, I can't remember, they had their first ever posting for the position of data scientist.
Uh-huh.
And so, So I think the issue is if you're building tools, you're building tools. That's great, and I think you do have. There is an element of having to understand what you're using, what you're building them for, but that doesn't necessarily make you a data scientist. If you're a software engineer, then you're a software engineer.
Yeah, sure. Yeah, well, yeah. So the way I deal with that, we've stopped putting out ads for data scientists. It's too broad, and not specific enough. So we say we want a software engineer that's going to work on this, or we're going to data apply statistician that's going to work on that, or we want a computer scientist that's going to work on this or that. So in the Department of Data Science, where we all have this commonality that we are working with data in this process that you described. Yeah. So we have a question from the audience. What does domain expertise fit in? Irrelevant? That's the question, not me.
Yeah, I don't think it's irrelevant. I think it's highly relevant to being a good data scientist. And I think it's part of, when you learn from data, you have to know what you have to know what you know, and you have to know what you don't know, right? And that's the scientific element. That's the domain knowledge that you have to bring. And so I think there's two things that you could think. One is that you can be the scientist, and the other is that you can kind of collaborate or communicate with the scientist. And I think that's why I feel like that's an element of being a data scientist that's not part of the data, but is a critical part of the job.
Sure. Right. Yeah. So I mean, if you, I don't know if maybe we'll see how it works out for them, but it is putting ads out for data scientists is, unless you have a job description that's very, then that'll help. But it does.
I think there's a process that's kind of happening now. So does the name Jim Barksdale? Do you remember that name?
You mean from The Wire? I don't remember.
I mean, no, it's
the Barksdale. I just remember from The Wire.
Do you remember Netscape Navigator? You were going back in time now, right?
No, I don't remember that.
You don't remember Netscape Navigator?
I remember Netscape. I don't remember the name associated with it.
So he started Netscape, right?
Okay.
And he has a great quote, which is that there's only two ways to make money. There's bundling and unbundling. Okay. Mm-hmm. And I think in many ways, the data science title is a bundling of just like a lot of different things that people were doing. It was hard to categorize, I think.
Yeah.
And I think what's happening now is the unbundling.
Okay.
And there was a thread on Twitter. I don't know if you saw it. It was Hillary Mason asked, what's the future of the title data scientist? Mm-hmm. And I think, and there seemed to be some consensus in the thread that like it's going away.
Yeah.
Sure. Yeah.
I mean, that's what I think too.
Yeah.
Teaching, even teaching a data science course is a little bit too broad. Like you want to be. It's not a course, right? If you're really teaching everything, it's unless you like pick a track, which is fine, right? Computer science is like that, at least at the graduate level. Like the computer science has like several tracks, and they have nothing to do with each other.
Yeah.
No? It's like computational biology and systems is like there's really not that much that both camps know, but they're both computer scientists.
Yeah,
and that doesn't happen in statistics. That's one of the things that in statistics so for the audience, well, both Roger and I were trained as statisticians in stats departments. So in statistics, that really hasn't happened. Like we kind of all know the same things, at least some basics. Our core is big, and like you can assume a lot from someone saying they're a statistician, that the things they know.
Yes, I think that's still true. Yeah.
And in a way that's, I think, kept us from being big players in the data science field, because we don't want to expand in any way. I mean, not me. When I say we, I really mean the academics in the discipline, at least the ones that preceded us.
Yeah, I think, but I think so I guess the question is, should there be a field, like, should you be able to get a PhD in data science?
Yeah.
I think that's the question that everyone's kind of wondering right now.
Yeah, I think right now I'm thinking, I don't know, maybe. It's because it could be like computer science, but you're gonna need tracks. If you do that, you're gonna need tracks. That's my answer.
Tracks within?
Yeah, within data science. What kind of data scientist are you? Are you a software engineer? Are you a applied statistician? Are you a machine learning tinkerer, or whatever you want to call it?
Yeah. I do think, though, I think it's becoming more clear to me, at least, that there is a core of there is a core that I think you would want all data scientists to know.
Yeah.
It wasn't necessarily clear to me like last year, no, but I think it's becoming clear to me what that core is. And it's not, to me, I mean, I think almost all scientists need to know how to program now. So maybe that's not really distinctive. But I think there is I think if you want to say like data scientists are specialists at something, there is a core there that I think they can be good at that others maybe wouldn't focus on.
Yeah. You have
you don't
you
agree,
have
I can
ideas. I
tell.
don't know. I don't know. We're still, like you're saying, we're still unbundling it. So you would say, so I remember I had a well, I can't remember when this was, but there was a conversation. That's what it was. I was being asked to help creating a data science master's, and I was trying to figure out, well, what does it mean? Who wants to hire these people? So I interviewed a bunch of different company leaders and that claim to want data scientists, and asking them, what do you mean? And some of them said, like a lot of the pharma people were like, all we want is biostatisticians, but we call them data scientists now. That was one group of people. But then there was another group, and this was not a small group, that said, we just want people who can like write C++ efficiently so that we can move data around in efficient ways and code these algorithms up so that big masses of data can. So that those two, what do you think those two are going to know in common? Those, unless we just say, no, one of you aren't. You are, but you aren't. But if we are going to include both those groups, that intersection, man, that's not. I don't know how big that is. Programming. They have to program the data, but
yeah.
Go ahead.
I agree. The intersection between like a kind of bread and butter biostatistician and someone who's going to write, tens of thousands of lines of C++ code may not be huge. But why are they writing the C++ code? Well, it's to analyze data, right?
Yeah, they need to know something, but how much? We don't know. Okay, so here's a question from Leon. So based on the article, 4 Jobs of the Data Scientist by Roger. I think that's you. Does each of the 4 jobs mentioned there become a job title in itself in the future?
Well, okay, so someone here reads our blog, apparently. Just a quick reference, the 4 jobs of the data scientists that I mentioned were scientist, statistician, systems engineer, and politician. So those are obviously already jobs. So in and of themselves. And I think I was trying to frame it as like, these are the skills that a data scientist has to borrow from in terms of these areas. So I guess the answer is already answered. But I don't think, I guess you could ask, well, if you're in a data science kind of field, is there like the politician track and the scientist track I'm not sure about that. So.
Sure, and we're talking, that's another thing we should clarify. When we talk about this, a lot of our thinking is in academia, like we're thinking PhD programs, and it could all completely change once you go to industry and they're doing their own thing and they have their own needs. And of course, we obviously have to be looking, and like I told you earlier, I before starting a master's, I did go to industry and like ask, what do you guys want? So that's when I learned. That's when I started getting this idea that it was much broader than at least we thought in academia.
One thing I think that's interesting about industry is that obviously this industry is not one thing. And I think there are companies that have kind of large data science teams, and they have like machine learning engineers, and they have kind of more product focused people. And then there are other companies that are more kind of, for lack of a better term, legacy. And they're often the product of just mergers and acquisitions, and they're just these kind of Frankenstein companies. And because their structure is like a Frankenstein nature, their data is not also of a Frankenstein nature. It's a different databases, Excel spreadsheets, and whatever. And I think there's a sense that like we need people to just handle this, right? And maybe those people are data scientists.
Yeah, just come in and fix this mess.
Exactly. Right. Yeah.
And tell me what to do.
Yeah. Right. And that's always a challenging situation. So I don't.
Yeah, and a PhD in statistics isn't gonna help there.
I'm not sure a PhD in anything is gonna help you there.
Yeah. Maybe in some something where you learn about databases and.
Well, clearly it's an organizational problem, right? In many of these cases, these hypothetical kind of companies that I'm talking about. So I think that's kind of recognizing that is important.
Cool. All right. Well, maybe that's enough about data scientists. So wait, one more. Do you think the core, this is from Benelton. Hey, Benelton.
Yeah, who's that guy?
Do you think the core for data science is enough to think about an undergrad program major? Are we going to do that? Are we to that direction sometime soon? Are we going, I guess, are we going in that direction sometime soon?
I mean, we're already there, right? I think.
There's no undergrads in data science, is there?
There are undergraduate programs.
Yeah? Like
Yes.
a major? Your major in data science?
Yes, I think Purdue has one.
Oh, I gotta go look.
Yeah, it's in health sciences, I think.
What do they teach you?
That I can't remember.
Biostatistics? Just kidding. Oh, so Jane Liang says Berkeley has a data science major.
Yeah, that doesn't surprise me. Okay.
Yeah. All right.
So
I'm gonna go look.
I think at the for now, Berkeley, I mean, I know they have a Data Science Institute. It's kind of it's engineering and statistics and a few other things, but I think now there's a focus on kind of skills, and I think going back to Ben Hilton's question, I think eventually we'll move away from just like teaching skills, and there will be a core, there'll be a theory, and there will be kind of a core kind of base of knowledge.
Yeah, we'll see. We'll be watching. I don't know. We'll be watching. We'll talk again in 5 years.
Okay.
I know that one thing. I'll tell you one thing I've noticed. So one thing I've seen now more than once is that these data science undergrad courses where they want to get them right when they start, right? It's like data literacy or whatever. They want to.
Yeah.
So they want to just teach data science right away. A lot of these courses are basically becoming Biostat 101 courses, but instead of Stata, they use Python. Right?
Yeah.
But it's kind of turning into something that already existed before. They're kind of rediscovering, oh, wait, I guess inference is importance and probability. So I guess we'll spend all semester teaching that because it takes a long time to learn.
Yeah. Can I ask you a final question, though?
Go ahead.
You don't have to answer. It just as like
just to think about for our next one.
Yeah. So, so Tukey, right? In his famous Future of Data Analysis paper, he writes that, we should teach data analysis like we teach biology, right? Like we get together in a classroom and we talk about what is it that we've learned? What is it that we know? Right. And therefore, what is it that we don't know? Right. So could you think you and I, and maybe a couple other people who have long experience in analyzing data, could get together in a room and say, here's what we've learned in all our years of experience. So is there anything there that's not in the traditional, statistics curriculum or machine learning curriculum, right? I would say for sure there is. There's lots of stuff that we've all just picked up, right? And so putting that together, so there's something there. I think, I think, what is it? How do we characterize it? How do we organize it? That's a question for the future. But it's not like there's nothing there.
No, there's not. No, but you see what you're describing is a data analysis applied. I mean, that's applied statistics.
Yeah.
So one.
But what is the core of applied statistics? We don't have that.
No, we don't have that. I know. I was about to say that one problem is that I don't know when it was, 1930s, where theoretical stats took over at least graduate programs in statistics, or they created many of them. And you did have applied statisticians in stat departments and biostat departments. Although for the audience here, you'll be surprised how many faculty in biostatistics departments don't really look at data. They might just look at it as a toy example. Am I wrong, Roger?
You're not wrong.
Okay. So but you did have applied statisticians in there. Like almost any stat department, you will see someone sometimes more than one person that actually is a hardcore applied statistician that's analyzing data for a living. Yeah, but they're there. They teach their students when they write their thesis.
Right.
There's no class. I mean, what
There's
you're saying
course.
Is there might be like a consulting course where you get some of it, right?
Yeah.
Like I remember Carl Broman would always be pushing for that course at Hopkins. I don't know if it ever happened, but yeah, but that's what you're saying is that now we kind of have to start that, and there's not that much already to go by. We could start creating it. I see. That's a good question. Yeah. something to think about.
For the
And
next
right,
step.
but right now, my answer to that is the way I think about how to do that it's mostly case studies based, like they do in business school,
Yeah.
you
Yeah.
know, where you just go through a bunch of case studies and that's the class.
Yeah. Okay. So here's my problem with that approach. I think it's important to have data, when you're teaching about data analysis. Um, but I think one issue with that approach, I don't know about the business school case studies, but I think one issue about this approach is that it kind of reinforces an idea that whatever you learn is just inherent to that case study,
Mm,
right? And so like when we go to the next study, there's nothing to bring over,
mm,
right? Because the next case study has a different data set and a different scientific problem and a different whatever, and there'll probably be some issues there, but there's a different case study, so forget it,
yeah,
right?
yeah.
I
So
think
you want some formality to it where there's some core principles you can teach that then can be applied.
yeah.
Yeah, yeah, let's get in a room and figure it out one day.
All right.
Oh man, well we are doing it in a way. Like we share some of our findings either through papers or in conversations or even on social media. You post some opinion of something that worked or some idea you have.
Yeah,
Ah,
it's happening.
yeah, it's happening. You're right. So here's a question. Well, this will be the last data science question because I want to ask other things.
Yeah.
What's the intersection between bioinformatics and data science?
That's a
Well,
question for you.
yeah, what's bioinformatics, first of all? If you can tell me what that is, then maybe we can answer this. But to, that's a good question because first, bioinformatics is another area where it depends who you ask. They give you different definitions. But one thing that they do have in common is at least a big subset of bioinformatics people who say they do bioinformatics is that they are analyzing data and constantly dealing with challenges that involve some kind of software engineering knowledge because the data sets are big and complex and you have to process them in different ways and build pipelines. So this is what I referred to earlier when I said that when that first article came out, that I think that's really when the data science term took off, Roger. It wasn't like Cleveland might have said it in the 70s,
No,
but
yeah.
nobody paid attention. I mean, academics maybe, but most people didn't really pay attention to that. It's really I think it's 2007, and you can see it in Google Trends that's, or was it 12? Maybe it was 2012. Somebody look it up and tell us. But you can see the trend if you just do the Google Trends for data science. Whenever that starts going up, that's when that paper came out.
Yeah.
And what I'm saying is that one of the things I said earlier to answer Sean's question is that when that paper comes out and describes this new thing that we do in industry, or at least in the industries that we're talking about, people who were doing bioinformatics, we're doing that too. They just didn't think to write that paper and call it data science. Same for astrophysics and other areas where they were doing similar things. Okay. So I want to reminisce a little bit about the old days.
That's what we do. That's what we do best, I should say.
So for those that have not heard of S+, that was the first statistical analysis language that I learned. I arrived at Berkeley 1994 to graduate school, and I didn't know how to analyze data. And then I had to learn S+, first day there. So S+ is, Roger has written really nice blog posts, and I don't know if you have articles too, published articles about the history of all this. But S+ turned into R, basically. I mean, R substituted S+. So I don't know if you remember this, but I don't remember exactly when you arrived at Hopkins. Was it 99? 03. Okay, 03.
Yeah.
So when I meet you in person, I had already heard your name because you were on our help answering questions.
Yeah.
So remind me, so how did I remember? I can't remember exactly when I did the switch, because at some point I had to say, okay, I'm not using S+ anymore. I'm done, and I have to switch to R. And I can't quite remember who was it, Roger or Carl, that made me do it. Do you remember?
It was probably a combined approach, I think.
Okay.
I think part of my job in the early days was convincing people to switch technologies.
Yeah, right. And one of them was start using R.
Yeah, I mean, I've been using R since '97, basically. So back pre 1.0 days. And the main reason is because it was free, right? I mean, I think it was S plus was really expensive, like SAS or whatever, and so I couldn't afford it. And R seemed like it did similar. The biggest problem is that R was not the same language, and so like you couldn't just cut and paste code that was written in S plus into R. Sometimes you could, but so yeah, when I got to Hopkins, I had used S plus, so I knew kind of how it worked. But
so when you got there, was there people still using S plus?
Well, besides you,
I wasn't. I don't know if I was. I might have switched already. I can't remember.
Yeah, I don't. I guess not. I can't think of off the top of my head if there were a lot of S plus people, but I have very vague memories of those early days. But I think it was. I mean, I know from teaching my class, so that I've been teaching now for 17 years, that there was convincing that had to be done to get people to use R.
Yeah.
Whether it was from S plus or Stata or SAS or whatever, there was a huge amount of convincing that needed to be done.
Yeah, that's what I remember, that you were doing a lot of that. And then all the faculty that was that agreed with you, we were all assistant professors, so not have that much influence. But I mean, it wasn't that hard for you to convince people, right? That was.
Yeah, and I think one of the things that's interesting back then, I think one of the big arguments was the open source aspect.
Yeah, that it was not trustworthy, or no, that's one of you're saying. I
Well,
remember.
it was both an argument in favor and an argument against.
Exactly. Yeah. So how did you tell us a little bit about how you, like, your history of learning to program and the languages you learned first, and how did you start using R? Like who in 1997? That's very early. So how did you find out about it?
Well, okay. So I guess since Wikipedia says I'm a software engineer, I mean, programming goes back pretty far. I started programming in college, just C, C++, that kind of, and I had so a number of jobs as a software engineer, and so that was kind of very early on instilled in me. In terms of, and then I didn't really get into statistics until kind of the end of college, and then I had to do like a project. And so I had to analyze some data, and so I went on, the best search engine available,
Netscape.
Yahoo.
No, Netscape was the
browser, right? Yeah.
Okay,
So I fired up Netscape, went to Yahoo, and did the directory search. You probably don't even remember Yahoo.
I remember Yahoo.
There was like a directory, so you had to go to like software, and then it was like statistical, and then it was like, and it had all these like links to like S plus, and then there was R, right? So.
So you discovered it on your own. It wasn't John or anybody at UCLA that told you about it.
No, I just found it on myself. Yeah.
Wow.
Yeah.
I didn't know that little detail.
So then I started using it. Then I went to graduate school, and nobody at UCLA is using R at this point. They're all using XLisp, right? So XLisp stat, right? So, and that whole department was standardized on XLisp stat, which frankly I loved. I loved XLisp stat. I'm a huge Lisp fan, and I love the parentheses. I love everything about it. So if I had my way, I probably would have stayed. But honestly, nobody else used it. It was basically like our department and Luke Tierney, right? So, eventually, when I left UCLA, they had converted everything over to R. And actually, Jan Delu has a whole paper about how he converted the department over to R and why he did it. And ultimately, it came down to the size of the community. I mean, XLisp had a very small community, and the R community was skyrocketing.
Yeah. I mean, that's really a big attraction to R. Even back in 2005, that there were so many ways to get help.
Yeah, exactly. Yeah. So I don't know. I've always had a love for kind of software and engineering techniques, and I think I've always feel like that's been one of the things that's made me. It used to make me unique in kind of the area of statistics. Now it's far more common, I think.
Yeah, I remember you were the software guy, and also the open source and reproducible research. That was the other thing. You were like, it was the new thing, and you were doing all that stuff. So we have not that much time left. So I want to ask you about two more things. One is about blogs. So we started this blog, Simply Statistics. How old is it now?
It was 11, I think 2011. I think we started.
So why did you start that blog, and why did you make me do it with you?
So if I recall, the reason we started this blog is just to kind of create a place for people that I think we thought of as applied statisticians, maybe data scientists, right? Could kind of like see things that they recognized, right? So, I mean, if you read the journals, you read the typical statistics journals, there was very little there for people like us, right? I think, and sure, you could go to the subject matter journals and there might be something there, but there was nothing in our field for us. And I think the general idea was that we wanted to create a place where we could write things and people could read things. And I wanted to be able to put things out there on the internet that other people could kind of bring to their department and be like, look, it's not just me who thinks this. Like there's other people, like Rafa who also thinks this, right? And so kind of have like a kind of a clearinghouse for for ideas about applied statistics, data science, that kind of thing.
Right.
Yeah.
No, it was, and I guess it was pretty effective. I don't know. I mean, a lot of people back then, a lot of people would comment when they would meet you that they liked the blog, and it was nice.
Yeah.
Like you said, it was nice to see somebody else that thought this. I guess some of the newer faculty now don't know about how it was back then.
How dark it was back then.
It wasn't that dark, but yeah.
No,
So do you think we should? Is it still? Should we keep it going? Like, is it now? Our blog's done. Our blog's still a thing.
I put together some data for you. Actually, can I share? Is it possible? For you to share
yeah, absolutely.
Just very quickly, one slide. I have some data for you. So here, this is our blogging output for the whole period.
Holy God! Look at 2012.
Well, 2011 was a partial year, so 2012 was like the first year, really, full year. And you can see, productivity has declined.
Yeah.
And I think what it comes to, and I think, so this is, I think, anyway, I'll take this off now. It's hard to keep up. I think the nature of blogging has changed now because of social media.
Yeah, because I think what happens now is people just do a thread on Twitter instead.
Yeah, it's like I want to get some ideas out there. I don't want to think super hard about it.
And then there's that Unroll app, whatever that is.
Yeah.
There's your blog post.
Yeah, and now when I turn to the blog, I think, this is like a real format. I need to think about it. Yeah. I need to have complete sentences and things like that. And it's like, forget it. So it can be a challenge, I think. It's now if you look at blogs out there, it's either like a professional or it hasn't been updated in 4 years.
Yeah, right. That's right. So there's like the pros that it's a newspaper for them basically, or opinion part of a newspaper, and like they make money.
Yeah.
And then people like us that were just getting ideas out. I think that has moved to social media or some other platform.
Yeah.
But you know what? If I had more time, I would, and I every once in a while I think I should put this on the blog. But the other thing I do, because again, like you say, it's extra work, is I'll just put an R markdown on GitHub.
Yeah.
Because a lot of my posts were, here's a data analysis I did, check it out, right?
Right.
And then I had the code, and I would share the code so people could learn or how to do or how not to do it or get criticized. I learned a lot by the comment section telling me how I was doing it wrong, by the way.
Right.
And there would be like discussions about how crappy my style was and how I never commented. So
it is bad. That's true.
Yeah. So okay, so that now it's like you can put it on Markdown on GitHub, and it's kind of the same thing.
Yeah, it's 95% of what you need.
Yeah.
Yeah. I think so actually I saw there's a comment, Ming Tan writes, it's hard to, a blog post is easy to go back to. So it's like a reference, right? And like things like tweets or maybe even GitHub posts, they may be hard to find later. And I think so something like an analysis might be, I mean, a tweet, I don't know if you want to go back to a tweet, but something like a full-on data analysis might be useful to go back to.
Yeah, no, that's true. It's true. It's a good point.
Yeah.
And I done it for one of my posts. You and Jeff did it for a few, where you basically sent that post to some journal and they published it. Like, didn't you get like Nature paper or science papers out of it?
Yeah, I don't know. Yeah, something like, so some of the blog posts that got more visibility, we've been approached by journals saying, hey, do you want to just publish that here?
Yeah.
Which it doesn't happen that often, but so it is kind of a different model.
But Ming is right. I mean, that's a good point. That maybe makes me think maybe I should put it on the blog, because then in a few years, maybe I'll take some of those posts and turn it into a little book or something.
Yeah.
It's easier to compile.
Yeah, I think the problem with blogs in general is that there's no real good monetization model. I think now, like, the key, you look at like email newsletters, that's like the new blog, because there's good monetization models for people to kind of support those things like Substack and and like MailChimp, they allow for people to kind of have memberships, and so people can get paid to do that. It's very hard to do that on a blog, I think, and a lot of people had to use advertising, and that's not really not great, and so I don't think so. I think that wasn't sustainable for people who wanted to make a living off of that.
Oh yeah, sure. I mean, we didn't want to do that. Like, I remember we used to get people send us books, and can you plug our book? We had a rule that we wouldn't plug stuff
unless it was our own.
Huh?
Unless it was our own.
Unless our own, of course. Yeah. So, all right, good. So, do you recommend? So, some new faculty, graduate students, postdocs. Would you recommend they start a blog if they want to get ideas out, or do you say try something else today?
Yeah, I think my general rule is you don't start anything unless you want to do it as your job, right? I mean, I think blogging. Actually, I gave a presentation on this. This is why I have all these slides available. But blogging is kind of like in the two-dimensional space of like rewarding versus effort. Is I think a lot of effort and maybe not so much reward. But it is rewarding, but it's like a lot of effort is what I mean. And I think other things like social media, I think is very little effort, but also I don't think is super rewarding.
Yeah.
And so.
So I don't know if you notice that Twitter is so, it has so, compared to what the appearance, the influence it has is not that big.
No, yeah, I think so.
It's like it's different. It's like it causes this impression of having this big influence, but then when you look at like concrete things, it doesn't really have that much of an impact. That's interesting. I just have started to notice that recently with like trying to promote stuff, and Twitter's not really the greatest place to get your work, to get your ideas out. In part because it's ephemeral and that it kind of just goes away real quick, and there's so much stuff out there, and also like what really is popular is people getting angry or offended. That's what gets the most tweets.
So my argument was kind of like was in favor of podcasting, because I think podcasting is actually not that hard to do. Like we're doing it right now.
This is a Zoominar, Roger, not a podcast.
Excuse me. Is that trademarked by Harvard?
By me.
Okay. But I find it really rewarding. It's easy to do. You get to talk to someone, and so it's pretty low effort. And in terms of impact, I don't know, but I mean, it's at least rewarding.
Yeah. No, that was my next question. So you have 2 podcasts.
Yeah.
So tell our audience a little, plug it to the.
So and the rationale behind the podcast is very similar to the blog. So I have one that's called the Effort Report, which is with Elizabeth Matsui, who's a professor at UT Austin, and then another podcast, Not So Standard Deviations, with Hillary Parker, who's a data scientist who just recently worked on the Joe Biden campaign. And the idea there was like, at least for Not So Standard Deviations, was to allow people to hear kind of how do
that one came first, right?
Yeah, that one came 2015. Yeah. And just to allow people to hear what data scientists talk about. Like
2015, can we see that graph again? See when the big drop was in posts?
That one's steady as she goes. Yeah. It's been twice a week for 5 years.
Twice a week?
Oh, sorry,
wow.
Twice a month.
Oh, okay. Twice a month. Wow. That's good. And what was it that made you like have this realization we should start a podcast?
Well, I think, like you and I, we were in the department, at Johns Hopkins for a while together. And that department, there's a lot of discussions in the hallway. We're talking about, we're working on this problem, we're working on that problem. Here's this issue that I'm confronting, And so there's a lot of just action that happens just through people talking, right? And it's not just about publishing papers and editorials and whatnot. There's people just talking. And some people don't have that environment. And so my goal was to kind of recreate that environment a little bit on a podcast so that anybody could kind of experience it and hear it.
Interesting.
And so, and I think the podcast medium seemed like the best thing at the time, and I think still is the best. I think the same is true in academia in general, not just the data science. Like academics talk to each other, mentor each other, in the hallway essentially. And I think that's kind of the rationale behind the Effort Report.
The Effort Report. I see. The Effort Report is about like. I'm sorry. I don't listen to podcasts. I only listen to like non-academic podcasts, but
I don't blame you.
and even not that many. So the Effort Report is about academic, like stuff like
just academic life. Yeah.
Okay. And not so standard deviations is about data science.
Yeah. And so Hillary Parker, she's been in industry. She graduated from Johns Hopkins. She's been in industry her whole career. So she has a very different kind of perspective than being an academic.
Cool. All right. So do you recommend people starting off earlier in their career in academia to start a podcast?
I mean, it's a very hard, broad recommendation to make, but I think it's worthwhile. We have you saw Stephanie Hicks in my department started one early on.
Yeah.
And so yeah, I think it's pretty casual. It's not like a huge effort, and I think it's like a very manageable type of thing to do if it interests you. So I would recommend it if you're curious.
Cool. All right, you heard it here first, people. Start a podcast, not a blog.
That's right.
So we have a couple of questions. I'll ask them, and then we'll wrap it up because we're over time, and I don't want to take more of your time than I told you I would. So one is from Sean Coining. Sorry if I said that wrong. What are the flagship publications, conferences, or societies for data science? I mean, that brings us back to our to our lack of ability to actually define it clearly. I mean, I don't know if there is one. I know that there's our studio conference is a very popular one, but I guess that's for people who develop packages and want to learn how to use packages. Very specific.
Yeah, ironically, I'm not sure I would characterize that as a data science conference.
Yeah.
So this is a very tough question. I can't say. Well, first of all, I just don't go to that many conferences in general. I tend to go to the usual statistics conferences, mostly just to see old friends, right? But
yeah,
I can't. I mean, I think there's so many conferences in industry that are kind of dominated by industry, and then there are a number of like kind of computer science-y types of conferences. But I can't say that I don't think that there's like a leading.
Yeah. So Sean, if you have like a thing you like what you do, you probably want to find a conference on that. So for Roger and I guess that would be something like ENAR or JSM.
Yeah.
But for me, it's the ones the conferences I enjoy the most are one session conferences. The no parallel sessions.
Single track
conferences on a specific topic where we're using statistics, right? So it'll be like on single cell RNA-seq, and it's a bunch of statisticians that work in the area, and we all get together. Then I go listen and I get something out of it. So that's the conference I go to, and those are in a way data science conferences, because all we're talking about is how to analyze these complex data sets. That includes how to deal with a bunch of the computational aspects of it.
Right.
But it's in academia. I don't know if Sean's in academia, but it's true that in academia, it's just hard to find data science conferences, because like I remember when I first started going to conferences in stat departments, right? I just thought these conferences there's no data, it's just a bunch of theory.
Yeah.
Right?
Yeah.
Then I started going to like genomics talks, and my complaint was there's no data here. It's just a bunch of like screenshots of journals.
Yeah, I've seen that talk.
And there's like 1 million plots per slide.
Yeah.
And the mouse is going all the little red thing is going all over the place. And then I started then these data science conferences they're called, or data science talks, and it's there's no data. It's mostly about software. Or opinions about software, or like people that have very strong opinions about software telling us about them.
Yes.
So it's like I never have found a play except these conferences that very specific, very like niche conferences that I've told you about, where you actually see data analysis being presented. Although where you do see it more consistently, it's in social sciences. The social scientists that use data, there's a lot of them. Their conferences, man, those are like really good applied statistics talks.
Okay.
But I mean, it's not my area. But when I go to these data science things at the university where they try to bring a bunch of people together, they're one of the few that actually show you some data.
Yeah, yeah.
Like the stuff with like showing the bias in sentencing and that kind of stuff.
Mm-hmm.
Those are great, and it's like data from the beginning.
Yeah, and look, here's how we learned this from the data, and yeah. It's funny you mentioned the software. I feel like a lot of statistics talks, instead of talking about a lot of math, now talk about a lot of code, basically. And it's the same in some sense, it's the same kind of abstraction. It's just using different symbols.
Yeah.
Yeah.
Any recommendations of our education specifically for medical healthcare purposes?
Oh wow, this question almost feels like it was planted there for me.
Yeah. Right. Shiva.
I do have a Shiva Srinivasan. All right.
Mm-hmm.
Well, I can promote my own things. One of the things that's ironic for me is that there used to be nothing out there for learning R, and now there's too many things to even choose from.
There's a lot.
So there's always my book, R Programming for Data Science,
Yeah.
available on LeanPub.
For free still, yeah?
For free, yeah, exactly.
Yeah. All right. Let me see if there's anything else. I don't think so. Well, any parting words, Roger, for our audience?
I don't have any profound thoughts, but thanks for having me here. It's fun to chat again.
Yeah, it was fun to chat. All right, and thanks for playing.
Yeah.
You still got it.
Thanks.
I saw the dust coming off, but
yeah, I tuned my violin just for you.
All right. Well, thanks everybody. I hope you enjoyed it, and we'll see you soon.